Hello, I've worked on quite a number of machines that take these tapes. It's called VCR, and in particular I've done several on the VCR-LP N1700 and similar machines. But I actually don't really need any more of those. I've had quite a few of them.
Special delivery.
All right. I wonder what's in this then. Included are some drive belts, which I don't know if these are relevant to this machine, but they're always useful to have. Aha. So this is the rarer model, at least rarer in my experience, the N1702, which has the 4-digit counter and some other detail changes, somewhat different clock. So I've done one of these before, and in fact the clock on that one was defective. So if I can't fix this, I will at least borrow the clock. But let's see first if I can fix it. Around the back we just have the antenna connections. This one doesn't have the AV output ports. Not yet, it doesn't. Something is rattling inside here, so I need to find out what's loose. This is the type that does not have the captive power cable. It takes a standard figure of 8 power cable, often known as a cassette lead, and I prefer that arrangement. But we're not even going to power it up yet. We're going to take a look inside. So there's a hatch. Hang on a minute. Oh dear. We're missing the video head drum. So this machine is not going to go as it stands. And I don't have any more head drums for these machines. So that's a bit of a showstopper, unless I borrow heads out of another machine just for the purposes of setting this up and testing it. Oh, that's a real shame, isn't it? Oh, do you like the way its head position sensor here is actually an audio cassette head? I think actually it might be an arrays head that's just being used for picking up the very low frequency pulses of the upper head drum rotation. There's quite a lot of aluminium oxide going on here, so that'll need a bit of a clean before a head is installed. It does come complete with the tool here, which I like to see that one. This can be used for cleaning the first tape guide, like so, because that's very critical to the operation of the machine. And this is a graphite earthing spring, and you can get a feel from that how much use the machine has had, because the head swings from one side to the other, and you can see that sort of arc in the graphite. And it doesn't look like this is very high miles, this machine, but no heads. That's a big problem. I have some knackered heads here. I don't know if these are N1500 or N1700, but they will do the purpose of filling that gap and allowing us to at least test operation of the machine later. That's not spinning very well, so I think this needs a drop of oil as well as clean up of the surface. Let's take a brief look inside, shall we? I'm going to look underneath first and then take the top off. Let's see what state the deck is in. With the head drum completely missing, there should be a pulley. I don't know where the pulley is going to be that connects to the back of the head drum. Ah, here's our pulley. That's what was rolling around. Okay, so that's quite important. We can fit the pulley on that gash head drum and fit a drive belt to it. The drive belt's not the easiest things to get hold of, but I have some. Oh, okay, there's the drive belt, and that feels too thick and not flexible enough, and I don't like that drive belt, so I'll fit a better drive belt for that. But the other drive belt, we've got the capstan belt in place, and the counter and the braking motor. The way this is used is very strange. They use a motor just for braking. It's the weirdest thing. Okay, so we can at least put a head in there with a different drive belt on the pulley and see if it runs. I might just go ahead and fit that junk head in here anyway. at least it gives us something more to work with. Okay, the ideal drive belt I think is 76mm by 5. This is 74mm, is one I was experimenting with, which I think is a little bit short, so it might be a little bit taut, but it'll do for now. We'll fit that in a moment. Let's start by cleaning some of the oxide off the top of the head drum. I'm just going to clean this a little bit so that the head doesn't foul on the lower drum. Okay, that's spinning a little better, but it's still not great. Hopefully the oil will work in a bit. Anyway, this isn't going to be the head drum it finishes up with at the end, because this is either the wrong type or knackered or both. Right, have I mentioned before how absolutely frustrating it can be to install this drive belt on these series of machines? It's just a horrible thing. Okay, we'll start by fitting that pulley, which is a couple of Allen screws in there. Right, there should be a little end float, and there isn't at the moment, so I've done that up too tight. Like that. You should just be able to get it to clatter slightly. I'm sure there's a measurement for that. Now you have the this prospect of fitting this awful drive belt. So this is what we have. Like I said, it's a 74 I'm using today. It should be a 76, I think. Let's compare it against the one that came off. We don't know how good this is. This is very rigid, doesn't feel good at all. And it is just a little bit twangier. So it's not going to be far away from the right size. But the problem is, you have to fit it around this pulley, which I'll clean a bit in a moment, and the pulley of the motor, which is under here. And it's just about impossible to get your fingers in there to do that. And I do wonder how they did it at manufacture. So I found the way to do this is to slacken off and remove. So there's 3 screws, 1, 2, 3. Take these out and slacken that one off. But don't take the whole plate off, because of course it's also got the capstan belt on. If you take the whole belt away, then you lose the capstan belt, and then you have the same problem refitting that one. So it's a bit of an exercise in patience. Actually, a magnetic screwdriver helps with this, and I don't think this one is, because you tend to drop the screw. Oh, it is just magnetic enough. Good. Now slacken off the top one. Alright, so that's slackened, but not, hopefully, so far that we will lose the capstan belt, though it's a possibility. Now you can pull this away enough that you can get to the pulley behind and get your belt over it. And it's horrible because it has a tendency to skip over the top of the pulley and get involved in the motor spindle. Eventually, if you're lucky, you'll get to this position where I have my finger keeping the belt taut and we haven't dropped this pulley, I hope. So we can now get that over the top of the head drum pulley there, and hopefully now both will spin. And we also need to be careful because there's a micro switch here that needs to sit on a pin that goes through the deck, so you need to not lose its position either. So operate that micro switch. Right, so let's see if the capstan belt is still in place. No, that's fallen off, you see. So that's all part of the frustration. So we now have the drum belt in place, but not the capstan belt. So in an ideal world, we wouldn't have dropped the capstan belt, and that would be just about the job done, but we have. So now we've got to try and manhandle that back into place without dropping the... Yeah, you get the idea. It's just maddening. So really what you need is a helper at this point, because what I need to do is take this off again, get somebody to help me keep that tensioned while I load this belt back on its motor pulley. I managed to get both belts on their pulleys. This capstan belt looks a little tired and I should replace that. But just for now, we're only trying to see if this machine's even worth fixing. So I'll just leave it as is. And the head belter, as I mentioned, is possibly a couple of millimeters shorter than would be ideal. Now you've got to put the screws back without dropping the screws or the belts. Right, check they still spin properly. Okay, that's good enough for testing purposes, but that capstan belt definitely needs replacement. Just looking down here on this board, we have some various ICs and power supply and control electronics here. And there's a particular IC, is it that one? Markings are completely gone on that IC, but I think that's the one, which is, yes, that is the one, where they've added a resistor. And that controls the regulator. So there's a 2N3055 transistor here. And that IC fails a lot and takes out the 12-watt power supply, and then the machine doesn't run. So if we have a totally dead machine, it'll be that. Right, let's put this briefly back together and have a look in the top and make sure all the PCBs are looking promising at the top. Okay, the lid feels like it's not been removed in a long time, which I suppose is a good sign. There we are. Okay, that looks it's a little rusty, but I've seen much worse. I'll have a look under here. We may need to do some lubrication around these sliders. They often stick. The play and record switches are intact. They can break up, but they're looking good. I think it might be worth powering it up. We fit the carriage. So we should be able to get it to, if it's in working order, be able to get it to lace up without a tape in there initially. And if not, we'll have to investigate the mechanical problems. So let's power it up. Okay, the clock comes on, and that is good. So if nothing else, that's a good clock module I could fit to my other N1702. Let's switch it on. Interestingly dead. That's interestingly dead. I would have expected it to lace up when you press the on button, but no. So that's unusual. Let me have a look at the switches. So there's a switch operation here. What do you have to do now to make it work without a carriage in it? I should push this lever down and this that way, and it should operate, and it's not. I can hear the micro switch, but this anyway needs a bit of lubrication because that's not sliding back properly. But that's not going to help because it should be lacing up at that point. So I need to investigate why it's not attempting to lace, as well as lubricate that lever. That one there. Okay, so having got this lever now working properly, sure, it still won't do anything. Interestingly dead. Is it a mechanical or an electronic fault? And I'm feeling electronic, actually. That's quite normal that when you switch it off, that spins. I've had quite a lot of faults on these caused by dead ICs. I even had one with 2 or 3 dead ICs that were all causing faults. So I'm going to blame the electronics. So I'm going to go down to the board at the bottom and look at the signals that should allow it to start lacing up. I've studied the circuit for this before, and though it was some months ago, so I've forgotten some of it, I did manage to fathom out how it's supposed to work. Right, we're armed not only with the schematics, but useful pieces of the service manual, which tell us what to do if things don't work, like 3C does not thread in, so that's good. But one thing I've already checked, because it's obvious, is to make sure that 12 volts is there. Now we think it is because the clock wouldn't work otherwise, but that's P51, and that should be there even when the machine is just idling as it is now. So I'll switch it on and we should have 12 volts. Good. Right, does not thread in. Check that the relay RE101 is attracted for a moment only when you press the on-off switch. Okay, so let's do that. So that's RE101. I don't think it's actuating. So we need to define that. It's 13 and 14. So are the coil contacts. And what I think we should see is pin 14 should be grounded when we press the on button. So let's try that. Switch that on. So it's high, and I press the on button, and it should go low. And it's not. Okay. So that means this circuit here with the flip-flop is not actuating when we press the on button. And it says if that's the case, check the threading in circuit here. So P63 and 64 should be either side of that on-off switch, I think. So P63, let's try that. That's at 12 volts. I press the button and it does indeed go down. And 64 is low and I press the button and it goes high. So the switch is working. So we could have IC failure in IC102. So we've got some debounce circuit going on here. Let's look at pin 1 of IC102. I've had that chip fail before. IC102 is up here. Pin 1. So it's at about 5 volts. Press the button and it goes down to about 2.5 volts. A little bit unconvincing, isn't it? And sort of droops downwards. Is it supposed to do that? No, I don't think that's correct, what's coming out of the pin 1 of IC102, but let's take it through to the transistor TS105. Have a look at the base on that one. So it's low and I press the button and it just stays there. So we do seem to have a fault in this area. Let's look at pin 15 of IC102 because we could have a problem with these switches for the timer and eject, which is low, and I press the button and it doesn't really move. And what's the supply voltage for that IC? Not incredibly sure if it's a 5 volt or 12 volt supply voltage. But let's have a look on pin 16. What do we have? 12 volts. It's feeling a bit like might be a failure in that IC. Pin 2 is not used, but it should be the opposite of pin 1. Let's see what that is showing us. Nothing. So pin 1 is just sort of drifting around. And pin 2 is just stuck high. I have to say, I do suspect IC102, which is a CD4027. And I have had one fail before, so it's not impossible. Do I have a spare part? Okay, that's a bit of luck. I have a RS Components 4027, but I will fit an IC socket before I install that. Unfortunately, when removing the IC, I broke a resistor nearby, so I'll just have to replace that as well. Okay, with an IC socket now inserted in there, and the resistor that I managed to break, a 1K resistor, now replaced, let's fit our new CD4027. That's installed, but that fell out, and I don't know what that spring is for, and even less do I know why it fell out. So that's a little bit worrying. I'll have to tackle that problem later. So our IC is installed there. Facing this way, it's the correct way around. So now we can see if when we power it up with the button on, whether it attempts to lace up. There it goes. Oh, good. Alright, it immediately shut down. You know, there were problems. But the fact it tried is a big step forward. So we had a bad IC. Okay, so it did attempt to lace, but it sounded like it timed out. So let's just investigate that. For this, we'll actually run it with the lid off. So it sort of worked. It tried to lace up, but I think it timed out. So I'm just going to have a look at that again. We've got the carriage off, and we need this down and that pushed that way, and then we should be able to switch it on. So I'll switch it on at the isolation transformer, press this button, and let's see if it tries to lace. Yeah, it's timing out because that's not travelling at sensible speed. So that'll probably just be a lubrication issue here. This all looks very dry. I'll put a little bit of oil around that and we'll see if we can get it lacing a bit faster. Okay, after a bit of oiling, I think I've got it so that it will lace up fully. There. But it's still unlacing. Where I can check it is, let's see if it laces up and the pinch roller runs. Yes, it does, but it's unlacing at the end, so it may be a lubrication issue with the levers under this board. Let's have a look. It looks like it's operating the switch properly here. I'm not seeing why it's switching off. It might be that this switch is not working properly. Okay, that contact is breaking okay. Let's check that the other contact is making okay. Yes, the switch is working okay, though whether the connections make it all the way through to the other end is another matter. But that switch is successfully detecting when it's activated. So let's just check again that it does go all the way in. Watch that. You can get a better view than I can, I think. Yes. All right. But for whatever reason, it's shutting down again. So we're going to have to go back to the board underneath and have a look at the signals there and see why it's issuing a stop command when it should be laced. It could be that it's not seeing rotation of the drum. That will have a similar effect. So we need to find out which shutdown signal is happening. Okay, I've worked out why the machine is shutting down. I actually found if I stick my multimeter probe in the right place, it stops it shutting down. And the place I need to stick it to stop it shutting down is the output of the protection head disk blocking circuit, which was that little head I showed you earlier. It picks up signals from the upper drum rotating above it and sends out signals, 40 millisecond negative going signals, if the head is rotating, and the machine thinks it isn't, and that's probably because the head drum I've installed is probably an N1500 head, and maybe they mounted the magnet and the little cassette head sensor in different places on the 15 and 1700 heads, so it's missing the magnet on the upper head drum and we're getting no negative going pulses, and hence the machine shuts down because it thinks that the head is stalled. So what we need now is good or bad N1700 heads that we can put in here just to confirm the machine runs. And so I find myself in this position of having to borrow the heads out of a working N1702 well, N1700, not N1702. But before I did that, I discovered that this machine is doing exactly the same as that, but for a different reason. I believe the problem here is that the belt has fallen off the head drum. So maybe this doesn't have the best belt, but you can feel that's not right. So I guess I should test this machine briefly, put the belt back on, test it briefly, confirm that the heads are good, and then we can at least temporarily borrow the heads for our target machine to get that one completed. So I've got to go into battle with that utter pain in the bum drive belt. So yeah, the belt's got a bit tangled up here. So this is what I was mentioning earlier can happen. The belt gets stuck around the middle. It sort of falls off the edge of the pulley and gets stuck on the shaft of the motor, and then it's a right old jam up. So you have to take this apart and put the belt on again. Oh, I just hate this design. This machine's got a captive power cable. I prefer the figure of 8 power socket. Right, this is awkward because the best way of doing this actually is to set the machine on its back. So if we take the connectors off, get best access this way. So we've got to go into the battle with that drum and capstan motor. Okay, you've seen me struggle enough times with fitting these two belts. You didn't need to see me do that again. But the belts are on this machine, which is one that's going to lend us some heads, hopefully. But first, we'll just check to see that it plays okay. We're still having head drum problems. Has it shed the belt again? Oh, well, belt's got snarled up again. Okay, this belt clearly is not adequate. I'm going to give up testing it. I'm just going to have to borrow the heads. Let's hope it all works. And then when I refit good heads to this machine, I'll fit a new belt to it, of course. Okay, so there are what we believe are good 1700 heads. I'll put them down safely. Here's our target machine. Changing the heads should be easy if we don't allow slack on that belt. So we need to hold the pulley here in position while we change the head drum over. Out come the incorrect and probably faulty heads. And in goes what we believe are good 1700 heads. Okay, a little bit of end float on that. Now this machine doesn't have any AV output, so we're just going to have to test it with the modulator if it runs. It might just shut down as it was, and then we have another problem to fix. Okay, now let's see if it will stay laced up. It's still shutting down. So there's some other auto stop problem here. The head is rotating, but it doesn't know it is. Let's just confirm that. So my assumption earlier that it was because it was the wrong head drum installed may be wrong, but it's definitely something to do with the head drum detection, because when I put the multimeter on a bit of the circuit that's involved in noticing if the head drum is spinning here, then the machine ran. When I put my multimeter here on pin 12 of IC104, the machine did not shut down. So that implies there's a problem with this circuit somewhere. It could be the head detection circuit, or it could be the IC. I'm kind of feeling like it might be the IC, because I was getting some weird voltages along there that were neither high or low. Now I did have my oscilloscope set up momentarily last night. I was looking for these pulses coming out that head, but they're quite hard to see, and I didn't see anything. I just saw plus 5 volts. Trouble is the timing circuit consists of a 22 mega ohm resistor and a small value capacitor, so it's quite easy to upset the circuit with just a multimeter. Let's again look at that signal coming from the, well, it's a head, but it's been hit by a magnet, so it's a pretty big signal. So we have our multimeter on IC104 pin 12, and we have the oscilloscope, which I'll show you in a moment, connected to P41. So let me just confirm first that the machine will run in this state. Right, and it's not shutting down. But look at that voltage strangely rising. Oh, and then it did shut down. It's very odd behaviour. The voltages here just don't feel right. And let's have a look at the oscilloscope. Should go up to 5 volts. And you should see negative going pulses. And we're not. We're not seeing negative going pulses from the head. That could be the root cause of the problem, the lack of those pulses. So it should have looked for negative going pulse and there wasn't one. So I'm not seeing any negative going pulses from that head pickup. But I'm also seeing very odd voltages floating around in this circuit, so it's hard to know where the root cause of the problem is. We definitely have a fault in this circuit, but what's cause and effect is hard to tell. And take a look at pin 13, which is the other input to this shutdown circuit. Low voltage fairly. And pin 14 just creeps upwards. How do we think the circuit's supposed to work? You get 5 volts with negative going pulses. So the transistor will be biased on, I think, most of the time with negative going pulses. Switching it off. This diode will pull down the voltage, I think, at the junction between the capacitor and the high value resistor. So the voltage goes up, I think, to switch the machine off. If it stops seeing pulses, the transistor stays on. No, there's a DC blocking capacitor. If it stops seeing pulses of either polarity, right, then the transistor will go off. Right, so it could be stuck low or stuck high. The transistor will go off. The voltage will go high at the R131 point. Nothing will be discharging C121 anymore, and the voltage will go high on pin 12 and the machine will shut down. That voltage creeping up could be because we're not seeing any pulses from the head. Could it be defective head? You know, it's not impossible. We're not getting any signal, so it could be a connection problem to that head. So we need to look at P41 and how it connects to that pickup head, which is underneath the head drum. That is an awkward place to get to. I'm not certain of the wiring from those pulses from that head and how it gets here. So I'm going to park that problem for a minute. What I'm going to do, the 2.2 mega ohm resistor, I'm going to shunt it to ground with a much lower value resistor. So it will disable the head disk blocking shutdown feature, and we'll see then if the machine runs, and if it does, then perhaps we can see if we get any kind of a picture. Let's fit, say, a 2K resistor from pin 12 to ground of IC104. So we can work on that fault later if we can get the machine working. Okay, I've fitted a 4.7K resistor, is what came to hand, between the diode and capacitor on the output of the head blocking protection circuit down to ground. So it's only fighting a 22 mega ohm resistor, so the voltage on pin 12 will remain low, and hopefully that will stop that cause of shutdown. If the machine still shuts down, there's some other cause. And we haven't ruled out the possibility that IC104 could be defective. But let's just see now if the machine attempts to run. So I'll power it up and I'll override these two levers and see if it stays laced. And now we can select play and it will. Okay, so that's operating normally, but the trouble is if the head does get stalled on a bad tape, the machine won't stop. So we do need to fix that fault later. Let's see if there's any life out of the machine first. Now, being a 1702 model, there is actually a test signal from the for the modulator, and I can't remember how to work it. Let's just try a tape. The tape counter does not appear to reset terribly well. Right. It doesn't sound right to me. It sounds like the head servo is going off on a tangent. Yeah, it just sounds like the head drum is going faster and faster. There it is. Oh, can we stop it? Look, you can see the drum's going much too fast. Right. Right, if I slow the head drum with my finger, which I don't like to do, we get something resembling a picture. Okay. So I'll have to trawl through the manuals. Does it use that same signal that comes back and tells the machine that the head's drum has been blocked? Is it the same signal as used in the drum servo circuits? It looks like it might well be, and that's missing, and hence the drum is just ramping up to top speed. Okay, I looked at some diagrams and worked out what the connection is between that head, well, effectively it's an audio head, that sits down in there underneath the drum, and the input to the head blocked circuit. And the connection goes via the servo panel. I thought it might. And specifically it goes via the ramp generator, which is U326 here. Well, we could quickly swap that out, couldn't we? So that's U236. Did I say something else? That's U236. And here is one from my storeroom. Okay, let's try it now. I think we'll hear whether that's working or not. No. You can still hear the head drum speeding up. So we need to look at the signals on U236 and work out why we're not getting the connection through, if you like, from that head, that audio head that's underneath the drum. Okay, let's refit its original panel. At least it helped us eliminate some stuff. Looking at the schematics, we should be seeing a 1.2 volt negative going pulse from the servo head, which is that little array's head or whatever it is, underneath the head drum as it spins, coming in on, well, it goes to the ramp generator at pin 17, or its input connector is A71, which is what I'm connected to with this oscilloscope probe. So we'll have a look at that, and I'm fairly sure for the servo to not be working and the tape block signal to be happening, I'm fairly sure we're not getting that negative going signal from the servo head. So we'll have to go and chase the wiring through. But let's confirm that. I think it's 40 millisecond pulses, something like that. Doesn't say on that one. Right, okay, and let's try it. Let's see if we get anything on there when we run the head. So we can hear the drums spinning up, and indeed we don't seem to be getting anything on the oscilloscope coming from that head. It's just sitting there at about 0.7 of a volt, something like that, and eventually it shut down. Okay, let's check the connection. Well, A72 goes to ground, so that's not much to connect there. So let's check the connection from A71 through to that servo head, which is a pain because we have to take the head drum out. This is really hard to debug because you can't do any tests on the circuitry that's underneath the head. You just can't get to any of it. It's horrible if you've got a problem in there. It's completely it's inaccessible, everything that's under the head. Right, let's just have a quick look at this connector, make sure that's plugged in. So A7, we should be able to see if there's a head sort of resistance, shouldn't we, between A71 and A72. We should be able to meter that. If that does go straight to the head, as the diagram implies, you know, it could be lying. Here goes. This is a key measurement, I think. And we see open circuit. So there's no connection at all on A71. And that should go from A71 and A72. That should go to the head under here. So we're going to have to take the head drum out yet again. So there is the red wire, the red screened cable that should go up here. So we need to find out if it's a cabling fault or if this head's gone open circuit or something in that area. Do you know, there's something I don't like about this multimeter, that you have to go through modes to go between diode voltage and capacitor and resistance and continuity. They should be separate switch positions. I just find that frustrating. Let's do the ground first. Let's look at A72 first, which is the black wire. I'd be surprised if that's not connected. Okay, that's good. Now look at A71, which is the screen cable. Right. And yet we see an open circuit. Let's go through our modes. We see an open circuit across there. Oh, well, we saw an open circuit across there when the cable was unplugged. Let's unplug it. So we're not measuring back into this circuit. Okay, this is our disconnected cable. Open. That's a nuisance because a lot of these screws are set here. They've obviously been sort of calibrated to get that head into proper alignment with the magnet on the bottom of the drum, which is there. So that's a nuisance. We won't know exactly how to realign that. It's probably done at factory using a jig that of course we don't have. There's other wiring on here as well, and I don't know what that is. We're having a spotter bother finding us the correct screwdriver bit to fit these screws, bearing in mind that they're full of that red gunge. Right, I'm stuffed. I can't undo that screw. It's starting to chew up. I've tried to dissolve the red compound in it, but it's having limited success. I am just losing here. Well, I've had it, I think. I can't undo that screw. It's just chewed itself up, and I'm not even going to say it was all down to having the wrong screwdriver attachment, because it actually destroyed one of my screwdrivers. The handle's separated from the shaft, so I was putting enough force on the screw, but it just doesn't want to move. Let's try to drill out that screw. Okay, I've got the horrible screw out of there, I think. Good. I was getting quite frustrated with that. Now, can we get enough room to have a look at the wiring for the head? Not a lot of space, all the wires are really tight. Every single wire is tight. Flip it upside down and let's have a look at the continuity or otherwise across the head itself there. Alright, here goes. This is the reading we need. Completely open circuit. So that head just went open circuit just for fun. Isn't that the oddest thing? My best bet is to salvage one of these assemblies from a scrap N1700 from my storeroom. It's going to be time consuming and fiddly, but we can do that. And of course we'll only be able to refit it with one of its two screws since the other one messed us up. Right, we will stop there. Okay, we'll stop here for today. I don't want this video to get too long. I did one the other day about this Sony J3 Digibeater, and that went on for well over an hour, and that's much too long, I think. I don't want them to do that, so we'll try to keep them a little bit more sensible. I think it's better for views. Now, at least we have isolated the real cause of the faults on this machine, and I do know I have spares that I can fix it with, albeit we're still short of one N1700 head for this machine. Actually, there's another machine over there that needs a head as well, so if anybody has any serviceable N1700 heads, please let me know. Right, I hope you've enjoyed what we've done here today. I'll do plenty more content on audio and video technology in the near future. Bye for now. Okay, here's what I got from my scrap machine from my storeroom. Interestingly, it had slotted screws holding it in, which you've asked me are better than the Philips ones that they had used. And let's just check. Hopefully we see some resistance across this head. About 145 ohms. That looks about right. Good. So this can go in this machine.